Naming acids and bases. Binary acids. HCl in a gaseous form is a binary compound formed from hydrogen and a halogen, in this case chlorine. When it is a gas, it is named hydrogen chloride. When it is dissolved in water, the resulting aqueous solution displays a set of specific properties called acidic, and the name of the substance changes. The name now changes to hydrochloric acid. The IUPAC name is aqueous hydrogen chloride. A second group of acids is named in the same way as binary acids. For example, the cyanide ion Cn negative will take the classic name for the acidic solution HCl aqueous and be known as hydrocyanic acid. See the table on the next slide for some further examples. This is a table that you should add to your quick reference guide on how to name chemical compounds. Next, we have oxyacids. The next group of acids is formed from various combinations of oxyanions, which are negative polyatomic ions consisting of a non-metal plus oxygen. H2SO4 aqueous, or sulfuric acid, is now one of the most widely produced industrial chemicals. It is used to make pharmaceuticals, detergents and dyes, and is a component of car batteries. Oxyacids. Another example is phosphoric acid, H2PO4 aqueous. This is also an acid formed from an oxyanion and hydrogen. Phosphoric acid is an ingredient in soft drinks, is a reagent in the manufacturing of fertilizers, and can be used as rust removers. They are classified as oxyacids and the incorporated oxyanions. Here is one example of the range of phosphoric acid. This table compares the classical name to the IUPAC name for a series of acids derived from a chlorine-based oxyanion. Add this to your quick reference guide. Now, what are the rules for naming acids and oxyanions? When naming oxyanions, omit the word oxygen and add the word acid. For example, name the acidic solution with the formula HNO2 aqueous. Consider the IUPAC name, see Table 3 from a previous video, hydrogen nitrite. Nitrite changes to nitrous. Drop the hydrogen from the front of the name, add acid to the end. So the final name would be nitrous acid. Here is a table for showing the rules for naming acids and oxy and ions. Writing the formula for an acid. For this example, you're asked to determine the formula for phosphoric acid. Number 1, determine the names of the ions involved. The ic ending indicates the presence of the 8-oxy anion of phosphorus, phosphate. The symbols or formulas of the ions involved: phosphate oxyanion is PO4 with a 3 negative charge. The cation in oxyacids is always hydrogen, which has a charge of +1. Their ratio: to find the ratio of the ions, use the crisscross method. For this example, you are asked to determine the formula for phosphoric acid, continued from a previous slide. See the ratio. To find the ratio of the ions, use the crisscross method. So we know that hydrogen is 1, PO4, phosphate, is 3. So we're going to use the crisscross method, and this gives us the subscripts for each ion: H3, PO4, 1. Divide each subscript by the highest common factor, in this case 1. The hydrogen ions and the phosphate oxyanions will combine in a ratio of 3 to 1. So the correct formula is H3PO4 aqueous. Now here's a sample problem. What is the formula for the oxyacid sulfurous acid? Solution: sulfurous indicates a sulfite ion, SO3 2-. So we have a 1 and we have a 2 as the charge. We crisscross with the H2 and the SO3. So the correct formula is H2SO3 aqueous. Sample problem number 2. What is the formula for the oxyacid hypochlorous acid? Solution: hypochlorous indicates one fewer oxygen atom than a chloride atom, ClO-. Crisscross. The correct formula, HClO aqueous. Acids and bases. Now we're going to focus on bases. All aqueous solutions of ionic hydroxides are bases. We'll learn about this more later in the course. So 2 examples: aqueous sodium hydroxide and aqueous barium hydroxide. Bases are formed by a combination of a metal cation with 1 or more hydroxide ions. Here's a little chart to help you remember.